Now, when I'm building my next application, I want to make sure I think about performance. And I want to bring in our friend Jerome to start talking about performance for web applications.
Hi,
How you
Jeff.
doing, Jerome?
I'm doing good. Always glad
Oh my,
to see all the content that's happening in .NET Conf.
we're nearing the end here, late on day 3. It's so good to have you as part of this. And if I bring up and I take a look at my agenda here real quick, you're going to be talking about performance with .NET 7 web applications, right?
Exactly. I'm gonna be talking about all geeky stuff around performance.
Oh man. Well, let me add in your slides here, and I will hand the conference to you. Take it away.
Thank you very much. Thank you everyone for tuning in. My name is Jérôme Laban. I am the CTO of the open source project Uno platform. And I'm going to be talking to you about the performance benefits of .NET 7, and especially for web application using WebAssembly. And I'm going to be diving into very specific topics around this. So I'm going to be talking a little bit before about why with Uno platform we're looking at .NET and WebAssembly specifically, and what we're contributing on top of .NET and contributing to .NET. And we're going to be talking about AOT improvement, threading support with a cool new demo that we're going to be publishing just right now, or it should be tweeted soon by our team. A bit of CMD support, and then JS import and export. And I know Dan Roth and Steve Sanderson talked about that a little bit before, I think yesterday or the first day. But I'm going to be diving a bit more into those topics and talking about the performance aspects of that when comparing to previous technique that existed before. So the Uno platform is all about creating applications across platform using WinUI, XAML, and C#. It's all about talking about the web and .NET and iOS, Android, and all the targets available. Linux, for instance, and we're running XAML on the web specifically. That's where we get a lot of traction. We're talking about pixel perfectness. That's something that's very important to us. Being able to have the same look and feel everywhere, but also specifics around if you want to be able to. And we're also talking about getting your applications cross-platform, but everywhere .NET runs. So that's the important part. Then always single code base, not having to do specifics around getting your application running across all those platforms, which includes doing things over to the UI, so showing UI elements and your content to show something to your users, but also parts that are not part of the UI. So that's the two sides of the Uno platform itself. Then a few additional topics that I'm not going to talk about here. We're free and open source, Apache 2. That's very important. When we started this, 4.5 years ago publicly, we were running for about 4 years before. So it's been 9 years now. It's been a while, and we wanted to publish everything for the community to be able to use what we've been doing and extend and being able to use all that goodness that was available on iOS and Android, and then when the web came in, extend to all of those targets available. And it's been quite interesting since then. And we introduced a few additional things like a Figma plugin and toolbox, to develop applications from designers and others. And then we have Visual Studio integration and VS Code integration. And now that GitHub has announced a free 60 hours for getting code spaces running. We have also you have also now the ability to be able to run your application inside of code spaces, whether it's for Linux or with WebAssembly. You can see what we're doing on GitHub, Uno platform/Uno, and it's quite interesting what we've been doing, getting to new targets, reaching new audiences, and it's a lot of fun. And we have a very large contributor to our code base, and it's Microsoft. And the interesting thing is that we have WinUI is very large. It has lots of controls, and what we've been doing is partnering with Microsoft and the WinUI team to be able to integrate the code that comes from the WinUI platform and the original source of it, and integrate that into Uno platform. So that means that Microsoft is practically the largest code contributor because we have large controls like a datetime picker. If you don't have a datetime picker or calendar date picker, you're probably not a platform. So that's the kind of controls that Microsoft has contributed, and that's very nice. And it's a huge control, huge control that if you've been developing controls, you know that it takes a lot of time to build. So that's the kind of things that are very interesting to get to. So lots of controls, lots of things to do left. We have lots of controls that need to be upgraded to use the official source code. So that's ahead of us. That's cool things coming. So specifically Uno Platform and WebAssembly. Uno Platform uses what is called the Uno Wasm Bootstrap. It's a package that we started 4.5 years ago, and it's on its latest iteration. It's based on a slightly modified build of the .NET runtime 7.0.100 that was been released 2 days ago. And the reason we have this, and we're not yet using the .NET runtime out of the box, is that we're using small modifications to the runtime to add new features, or to add slightly modified configurations, like the fact that we enable file system by default, which is something that the .NET runtime doesn't do by default. So things like that. Uno renders the UI using the HTML DOM when running in WebAssembly, and I'm going to be showing it to you in a few seconds. It's compatible with WebAssembly Thread and SIMD, which I'm going to talk about later on. We provide a profile-guided AOT, and some of the demos that I'm going to be showing are doing that kind of feature showing, and that part is very interesting. It's all about taking what would be running using the interpreter for WebAssembly, but compiling it to run a lot faster using AOT, but only with what your application is using. So you don't have to compile the whole application to get there. So you have performance benefits with the size benefits. The Uno platform also provides memory profiling tooling, which is something that we're enabling with our custom build of .NET Runtime. And we also support native library variants. So that one is particularly interesting with the introduction of SIMD and threading, and it allows to have optimized version of library based on what the browser supports. So we're going to be talking about that a little bit more afterwards. With regards to applications that are live and currently running, we have the NuGet Package Explorer, and let me show you that one already. So we're .NET Conf, so NuGet is the most predominant package type that we're going to get for that conference, and we developed that application in collaboration with the NuGet team. NuGet Package Explorer team, so that you can get the ability to browse and analyze packages that are published on NuGet.org. And basically, it's like NuGet, the JSON, Newtonsoft JSON package, and you can open that, see the publishers and links and dependencies. You can even get to DLLs and see what's inside, like assembly, PBInfo, metadata references, and all of this is using the Windows Community Toolkit. This is the data grid that's coming from the Community Toolkit, so pretty cool tool that's available, and we can leverage because we're using WinUI, and Community Toolkit is based on WinUI. So one of the cool things that we can do with this. So NuGet.info, you can take a look. It's an amazing tool. We have the Uno Playground, which is the ability to test the Uno platform directly in your playground, so in your browser. So for instance, you can edit your content right away, modify, see what we're doing, and things like, for instance, test a viewbox, for instance, and see what that does directly inside of your browser. So that's another type of application that we have available. We have also the Uno Gallery that allows to show all the content, the features that we have with the support for Material, Fluent, and Cupertino, all of those design styles and design systems that are available, so you can use in your applications. And I was talking about the date picker. That's one of the features that are coming from WinUI directly, so it's pretty cool to see. And then we have the Community Toolkit Labs, and XAML Llama talked about that yesterday. It's an application that was developed directly by the Community Toolkit team that will include the Rive player support that was announced yesterday. So pretty cool to see. So take a look, and gives you an idea of what you can do with all the features that are provided by the Labs team at the Community Toolkit. So that's about some of the applications that we've been working on with WebAssembly that are public. There are many others that are running public or not public. So that's one of the cool things about developing an open source project. We don't necessarily know who's using that, but who's using our tooling. But that's the game. So people have been playing with this, and some contributor has been creating applications, games, and you can see that on our Twitter. Browse a little bit, you're going to see all those. We're not doing games, but people are doing games with Uno, and that's pretty cool to see. So that's fun. Pretty versatile to see all this. Now let's talk about the details. About the AOT improvements, and I'm going to dive into a bit of demos there. The cool thing here is that we've been working with Microsoft and the .NET team, for WebAssembly team, to get everything running and faster. And one of the things that happened during the .NET 6 timeframe is that every time you had a try-catch, try-finally block inside of a method, it would be removed from the AOT compilation, and it would just be interpreted. And what happens is that when you do that, it gets to run very, very slowly. And when we're talking try finally, it's not just the try finallys that you have explicitly in your code. We are talking about those that are embedded with a syntactic trigger for each, using locks, iterators, and many others. So practically it's everywhere. So that means that your code may run a bit slower or significantly slower, up to 25 times, which is the difference between running with AOT and non-AOT, plus a little bit of the fact that you have to jump between AOT code and interpreter code, so it takes a bit more time. So I'm going to show you with that demo how we've seen that and how we debugged the fact that we could improve that part. So let me show you quickly the demo that does that kind of test. And basically it's I have a main method here. So this is a simple project that does just plain console, doesn't have any UI, and we're going to see everything in the console. So what it does is invoke a method, and that method has a try catch, returns just a new value that's plain and simple, so it does minimal impact. And then we measure how long it took to get to the end. So I have, just to spare some time, I've built the app twice, the one with .NET 6 and the one with .NET 7. So that first tab here is with .NET 6. So I just pressed F5. I'm going to show you what happened. So the try catch took about a second to run that number of iterations. So it's about 1 million, I think, or 10 million. Okay, so it's okay, but it's an empty method, so it takes a while. So what we can do is when we're profiling methods like this, we can open the debugger profiler here and go to the performance tab, and then click on that button, refresh, then stop again. And what happens is that you'll be able to see what the browser was doing during that time. And if I just scroll down a bit, you're going to be able to see that when I'm invoking that test try catch method, you can see that, so those methods are AOT compiled because I can see the method name, which is something that is particularly specific to be able to view content here. And the second part is you can see that we jumped through interpreter mode here, and it's one of the reasons why it's slow. So now if I do the same thing with the AOT compiled version with .NET 7, you can see that now we're down to 44 milliseconds instead of a second, which is pretty nicely faster. And if I do it again with the recording and refresh, then we're going to see that now if I go to the execution of that method, if I just scroll down a little bit, now we can see that we're in a try catch and we're inside of the method, but there's nothing else included in there that was added by the runtime. So it's actually executing just that and nothing else, no interpreter, no anything. So it goes a lot faster. So that's pretty cool to see. It's something that we spent a lot of time trying to debug with the .NET runtime team and got to something that was a lot faster now. So let's continue. So that was Wasm profiling. Now, another one that's interesting is that WebAssembly now supports WebAssembly exceptions. So it's something that allows for the browser to allow for applications running WebAssembly to use WebAssembly exceptions directly. So it avoids that block of code that's behind here. So every time there's a method that was using try, catch, or finally inside of a .NET code, then it would have to go to JavaScript, then back to be able to execute the code that's inside of the method. And just doing and using that feature that comes from WebAssembly and that's been included in the .NET runtime, basically spares twice the, it goes twice as fast as a result of not having to jump from JavaScript back to our .NET code when it's been AOT compiled. So one of the cool things to get there. WebAssembly exceptions are supported in all browsers now. So that means that if you're running on .NET 7 using the Uno platform, it's going to be running everywhere. And that's pretty cool to get that small boost of performance there because exception handlers are everywhere. Threading support, now that's a cool one. So the .NET team has been working on this, and on the .NET 7, the new support has been added so that we can have threading support. And it's in experimental mode right now, but it's based on web workers and shared array buffers supported on all major browsers, which is very interesting. It requires native dependencies to be rebuilt, and the Uno platform is providing something to have feature variants there. And very quickly, when we're taking a look at a NuGet package that has support for variants, when you're building an application that has the support for multiple versions of flavors, we can see here that Uno supports Emscription 3.1.12 with multi-threading, then SIMD enable, single-threaded, and single-threaded with SIMD. So that's the kind of things that we're doing to enable the support for all of this. And this is a library that does SQLite, but there's also C# that has support for it, and I'm going to be talking about that afterwards. But that's the kind of things that we need to do to be able to support native code integration into your application, whether it's your own library or anything else. There's also the back and forth with the main thread. That's the kind of cool things there. And the .NET team added a new synchronization context that allows us to go back and forth. So that's pretty cool. So now let's go to the demo. So I have an application that is pretty nice. This is a ray tracer that's been developed by a contributor an open source contributor on GitHub. And what we did is basically port that code so that it does a bit of rendering. And if I show you the original version of that was running with non-threaded code, if I click here, you're going to see that the button here is still doing. So that one is using the WebAssembly version, the AOT version. But it's during the rendering, it stopped doing anything. So it takes a while to get there. It's a 0.5 seconds. This is quite fast, but it's still slow in a sense that it blocks the UI. So what we've been doing with that application is transform that into using basically task.run, and we're taking that renderer and running it in multiple times in the same app. So what I've been doing here is just a new application that uses a slider here, and you can see that I'm down to 30 frames per second, and then I can add more here when I increase that, and you can see that they're all rendering at the same time. And just to show you that I'm not faking it or anything, it's actually really using threads here. And you can see that now that I'm using all those images that are running inside of the app, the number of threads and the consumption, CPU consumption has gone up. If I push a little bit more, then it will go up. So you can take that link and run it on your machine. It takes a bit of CPU, and there's still plenty of things to take a look at with performance-wise. But it's pretty cool to see that plain and simple .NET code that runs threading is able to run in the browser using locks and anything that you need to do with synchronization primitives, running multiple threads and sharing memories and all the things that you need to do to shoot yourself in the foot, because threading is very hard, but it's possible. So we can do pretty cool things with all this. Now, threading is all shiny and things, but there are many things that may not work completely there. So for instance, running with threads requires a specific set of headers. So you need to set the co-op header and a co-op headers, and those enable what is called a secure context. And that secure context basically prevents you from accessing many things. So you have to have other sites that do particular, that need to be setting their own corp. Every time I'm missing a line. So corp headers, so cross origin, so that you can access everything. So you may miss access to this. Everything that goes with being able to do SSO is going to be a problem when you're enabling threading because of those things. So the sites that the resources that you're using have to be enabled to support this. There are a few other things like array buffer and being able to copy array buffers from one site to the other, and particularly in C# we had that problem where you can't copy the content of an array buffer that comes from the WebAssembly memory to a canvas. You cannot make a view out of it, so it's actually slower. So you need to copy the content. So a few things like this that need to be thought through. And one of the final thing is the fact that JavaScript APIs have threading affinity. So for instance, if you're, let's say, opening a file through the file open picker and then you're going to try to use that on another thread, then it may cause some issue because the handles are specific to a web worker. So you're going to have to switch between web workers in that context. And fortunately, Uno has the ability to do those kind of things. And we're currently moving to adjust the runtime and our libraries to take care of this and make sure that the APIs that you're using are staying on the proper context so that it doesn't fail. But just so you know, there are a few things that are there that may cause some issues. But it's still a lot of fun to be able to do threading. It's been a very, very largely asked feature for .NET developers. Let's continue. The next one is about interop and JS import, JS export. So it's the ability to go from C#, so from JavaScript to C# and to .NET from JavaScript. And it allows to go back and forth. And when we've been doing performance measurements for those specific features, we saw about a 2x performance improvement, which is pretty nice, twice the performance just in calling empty methods. So and the cool part about this is that it uses source generators to have managed zero cost initialization, and it's something that's particularly important because if you're doing things like for instance .NET marshalling with DLL import and things like that, that costs a little bit because there's reflection that needs to be done there, and that in that case it's not needed. So I'm going to show you what that means to take a look at that specific feature. So in that JS interrupt test, what I'm doing here is I'm calling a method that's imported here. So I have the test callback here that's called JS import. And the cool thing here is that I can call a method that's global in JavaScript. So I have that test callback method that's available in my JavaScript here. So test callback is here. And what I'm going to do here in that test callback is call a .NET method that's called my exported method here. So I'm going from here, that C#, then calling that method here, then calling the exported C# method that's called my exported method here. So what I will do, it will just back and forth jump in between. So maybe you'll have a little bit of time, not too much, but may be able to execute that. But what I wanted to show you is the fact that that piece of code here is actually generated code. And it's something that you can see now when you go into the dependencies analyzers and you go to the JS import and JS export, and you can see all the code that's generated for all of those. And the cool thing is that all of this is pretty intense in terms of memory consumption. It's zero allocation with ref structs and invocations that are zero allocation with static lambdas and others. So that's very cool to see. And I know that there's going to be a lot more performance improvements that are going to be baked in all of this, particularly in the JavaScript side, but that's going to be fun to be able to work with. And one of the other part that's of interest is that you can pass in delegates or lambdas. So you can see here that when I start the application, I'm going to write the navigator, and the navigator is going to be invoked. It's a lambda that's passed in here. So that's a C# lambda that's coming here. And I'm calling that action of string with the user agent that is coming from the JavaScript side. And what I'm gonna be showing here is the navigator that's been back and forth by just calling a lambda. And if you've been following .NET since the beginning for WebAssembly, that was very difficult to do. And now it's super easy. Just invoke a method and you're done. So very nice to see. So let's continue a little bit. And the last one is SIMD. So I'm not going to expand too much on that one because there's a lot of work that's coming up on .NET 8, and there's already new stuff that's coming in. But there are pieces of .NET that are enabled to go a lot faster when running with SIMD, and that is a proposal that is enable on most browser except Safari at this point. So the thing is that you cannot enable it blanket for everyone, because if you want to have people that are going to be using Safari, it's not gonna work. So if you want to know when that's going to come up, you can go to webassembly.org/roadmap, and you're going to see what your browser is supporting, including SIMD and other features that may come in the future. But it's pretty cool to see, and it's usable through when AOT is enabled. So if you're using the interpreter, it's not going to do much, aside if you're using native libraries like C# or SQLite that have been built using SIMD enabled, if you're building for an app that uses both of those. I think the coolest part is going to be .NET 8, where you can see that they've merged updates with, let's say, min and max for enumerables are now optimized for integers using SIMD and vector 128. So that's pretty cool to see that you're going to be going to performance, new performance horizon as a result once all the browsers do support that. So that's it. And just a last call for collaboration on Uno platform. If you wanna join us to develop all those cool apps that are on the web and to perform on code running on a browser, join us at Uno platform/Uno, or on Discord or Twitter. And that's it.
Oh my gosh. Jerome, you've landed on one of those topics that's close to my heart. Building and performance inside the browser with Blazor and the various WebAssembly things. I love this topic, and I really appreciate how you went in and showed the code that's generated for the JavaScript interop.
Yes.
That's really cool stuff.
That is amazing. Source generators are opening so many doors to be able to do super performant code. It's amazing.
So I have a couple questions for you that have come in from YouTube and from Twitter. Let me go to them real quick. I have Jose on YouTube asking, can Uno apps be compiled as ready to run in native AOT?
They are, as of I think yesterday. It's something very new. It's so it's not WebAssembly specific, but it's something that goes for the web, for Linux and Windows. So native AOT is something that has been evolving in the ecosystem, and now it's possible to do with the Windows platform as well. So we have a APR that may be closing or just coming up. So take a look on our repo, and it's going to be available very soon.
Fantastic. Last question I have for you is from Jay Sakamoto on Twitter, asking, can I build my class library written in C# for the browser platform with Wasm AOT, pack it into a NuGet package, and then use that package from Uno or a Blazor Wasm app?
Yes, you can. Yes, you can. So, well, actually, so if you want to, so AOT is something that is done by the app at the end. So it's not something that you can pre-compile in a sense. Now, the only thing that you can pre-compile is native dependency. So let's say if you have a C or C++ library, you can pre-compile that and get it to be embedded into your project. And that's something that I've shown a bit before using the SQLite library. So this is precompiled using C code that comes from the original SQLite library. But if you're doing .NET code, that cannot be precompiled. It has to be compiled by the app using it. And one of the reasons is because of the linker. If your library is big and the user uses only one function from your library, you may not want to AOT everything. You may want to just compile just that one method that the user is using in your app, in his app.
Fantastic. Thank you so much, Jerome. And if folks want to get back in touch with you, they can check out the Uno platform. Where on the web?
It's platform.uno. I forgot to put it there. So platform.uno
Teed
or
that one up for you there.
forgot about that one. So platform.uno or using our Twitter handle, so Uno Platform.
Fantastic. Thank you so much, Jerome. We'll be in touch. Have a great rest of your day.
You as well. Thank you very much.
All righty.